Good afternoon, ladies and gents. My name's Andy Lannigan. I'm a civils project engineer from Scotland. My co-presenter today is Hunter Common. He was the CEM, the Contractor's Engineering Manager for BAM Nuttall on the project. And today's presentation is about the Borders, the newly opened Borders Rail project. See how this works. Well, just a quick overview of the agenda we're going to discuss. So I'll cover a brief history of the route, which I think is kind of important when you're talking about borders. A quick slide or two on a case for reopening. The key remits, the remit and the key outputs. Hunter's going to take care of the engineering challenges, including construction, innovations, which is really what we did better. There won't be innovations to everybody in the room, because I'm quite sure some of the things we're going to discuss there people have already done, but for us, for IP in Scotland, those were innovations. Quick one on the celebrations, something to do with the Queen, and we'll have a Q&A at the end. The route itself, the historical route. Can everybody hear me? Yeah. On the left-hand side, what you see here is the WAVERLEY route, as it was called. It was actually named after novels by Sir Walter Scott. And you see it used to run from Edinburgh through Gala Shields, Gala Shields is probably, no, not going to him yet. Gala Shields here is probably the biggest population centre south of Edinburgh, between there and Carlisle. Ran through Hoyk, all the way to Carlisle. Just to put things into context, that there's the West Coast Main Line, that there's the East Coast Main Line. And other parts that might be of interest, because I'm going to talk about it in a second, there's Newcastleton. The slide on the right is just to show how long the railway's actually been here. It's Glen S Viaduct, which is just at Dalkeith, which is just there. And it's constructed in 1830 by the Edinburgh and Dalkeith Railway, and it was basically built as a horse-drawn wagonway to service the mining and wool industries just south of Edinburgh. Now that later became what you can see on the left-hand side, the WAVERLEY route. That was actually built in stages. The first stage was completed between Edinburgh and Hoyk by 1849, and the next stage between Hoyk and Carlisle was completed by 1862. And that continued to serve the wool and mining industry, as well as become an important lifeline for the local communities down the route. Roll forward 101 years, and steps the villain of the piece. For anybody that doesn't know, this is Dr. Beecham, and his infamous document, The Reshaping of British Railways. Within this, he recommended the closure of the WAVERLEY route. British Rail gave formal, and that was in 1963, British Rail gave formal notice in 1966 that they planned to close it. There was a considerable number of public objections to the closure, so the closure was given a reprieve and delayed until the outcome of a public consultation in 1967. That took place, and in 1968, the then Transport Secretary, Richard Marsh, gave formal notice that the line would close on the 6th of January 1969. This led to a public outcry and culminated in a 10,000 name petition being hand-delivered to 10 Downing Street. And here's a couple of pictures to show it. There's the petition being hand-delivered. A couple of key people here of interest as I go forward. That gentleman there in the brown suit is David Steele, MP. This lady here in the tweed suit is a lady by the name of Madge Elliott, who we'll see a wee bit later on. And just to understand, you can see the feelings of people all the way down the route to the closure. So here we have no trains, no people, no trains, no jobs. And interestingly enough, if this actually works, please notice the infamous, if you can see it there, the infamous black coffin. You see it there? That basically, every time there was a demonstration, that got wheeled out. But everything was in vain. Roll forward to the 6th of January 1969, and I mentioned earlier Newcastleton. This is a scene from Newcastleton level crossing on the night of the 6th of January. The last passenger train that was going to traverse the route was the 2156, Edinburgh Waverley to London St Pancras. But due to tampering in a line on the run-up to that, a pilot engine was sent ahead to prove the line. And when the pilot engine arrived at Newcastleton level crossing, This is the scene that actually it found. During this disruption, the local minister was arrested. and there was also a rumour that an elderly lady handcuffed herself to the gates. Now, I'll leave it to you guys to determine what an elderly lady would be doing with a set of handcuffs. But if I was a betting man, this would be the lady in question here, because she's got a firm grip in the gates there. But anyway, the last passenger train arrived, and just so happens that David Steele, once again, was on the last passenger train. He got off it, negotiated the release of the minister with the police, addressed the crowd, and persuaded them to let the train pass. It arrived 2 hours late at Carlisle, and so ended the Waverley route as a passenger line. Now, it continued to run freight up to 1972, when all assets were removed. Now, the case for reopening. Why was there a case for reopening? Regional GVA per capita. GVA is gross value added. That's how much each person brings to the economy per head. So the national average for Scotland obviously is in the middle. Edinburgh, which is at the north end of the job, is at the top. That's where all the money is. And Scottish Borders, which is at the southern end of the project, is here. And the next council south of Edinburgh is Midlothian, which is here. So the case for reopening was simple. Let's get the wealth of Edinburgh and bring it south. Some key investment objectives. Promote accessibility to and from the Scottish Borders and Midlothian to Edinburgh and the Central Belt. To help strengthen and grow the Scottish economy. Foster social inclusion by improving access to key services for those without a car. Prevent population decline in Midlothian and Borders by giving access to Edinburgh's labour market and opportunities for all. And create a modal shift from the car to public transport. And to understand, the route down to Gala Shields and such like is on the A7, and it's not the best road in the world. It's a bit of a rat run, so I would call it. Moving forward, the Borders Rail timeline. So in 1969, the line closed, and from the day it closed, there was action groups and people trying to get it reopened. In 1999, a feasibility study into the reopening took place. 2003, a bill was lodged with the Scottish Parliament. 2006, royal assent becoming what would then become the Waverley Railway Scotland Act, which is just this document you see on the left-hand side. So unlike my previous presenter, we had an Act of Parliament which gave us powers. I should say we didn't have an Act of Parliament, as I'm about to describe. Now, at this point, Network Rail were nowhere involved. So 2008, the authorised undertaker moves to Transport Scotland. What's the authorised undertaker? That's the person given the ability to enact the powers given by the Act of Parliament. 2010, advance works begin, DBFM. The Scottish Government had a different model for what would be the Waverley, what would become the Borders Rail. They wanted that to be a private railway. So Network Rail's only involvement was to provide the tie-in to the main line, but this would be done in a 30-year maintenance, design, build, finance, maintain. So at this point, they produced a reference design and 3 consortiums get involved pricing the project. And the price range was between 235 and 295 million. As 2010 went on, due to risk and uncertainty, the consortia started pulling out until eventually towards the end of 2010 there was only one left. At that point, Transport Scotland approached Network Rail. Fate played a part at this point as well, because just at this time here, when they were looking for a new partner, we had just recently completed, IP had recently completed the Airdrie Bathgate project, which was a 30-kilometre stretch of double-tracked electrified railway that had previously been closed by Beecham. So Transport Scotland had a great deal of confidence in IP in Scotland at this point. Oh, sorry, I missed a very important bit. In 2010, the Scottish Transport Minister turned over the first sod of ground. This activated a clause within the Act that said the works had to be completed in 5 years, which is very important as we move forward. So from 2011 to 2012, we under Network Rail, in conjunction with BAMS, our partner, we undertook ECI and AIP development, but we didn't have we were at grip 3-4 here. We had no involvement in the development, so we're a bit tied, and bearing in mind the clock was ticking from here to deliver in 2015. November 2012, an authorised undertaker was transferred to Network Rail. At this point, we then awarded the main contract for design and build to our friends BAM. March 2013, we mobilised to site and actually started our earthworks in April 2013, which was very quick because we would expect, we got a very good summer, which is strange for Scotland. And June 2015, completion, started driver training. September 2015, opens to the public. Easy. Easy. Anyway, the remit. We create 7 new stations with parking, 55-minute running time from Tweedbank, which is in the south end, I'll come to in a second, to Edinburgh Waverley. Half-hourly passenger train service. Class 158 and 170 rolling stock operating in 2, 3, 4, 5, 6 train formations. Non-electrified but passive provision for future electrification. Control and command signalling from Edinburgh Signalling Centre. And we also had to create passive provision for a 15-minute service to Gore Bridge, which you'll see in a wee sec. So here's the new route as proposed. Now, interestingly enough, when I showed you the original route, I pointed out Gala Shields. So there's Gala Shields there. So the original Waverley route was 106 miles long. This route is 30 miles long, 50 kilometres. When constructed, I think I'm correct here, this was and actually is to date, excluding HS1, the longest domestic railway built in over 100 years in Britain. So some key features in here. We start at Shawfair in the north. There's a wee line in there that says the 720, we'll touch on in a minute, the Edinburgh City Bypass. S-Bank, new station, Newton Grange, new station, that's also, and I don't know if I've got enough time, that's where the National Mining Museum is, so that gives you an idea of how much mining's in this area. Gore Bridge, that was another new station. Fallowhill Summit, everything rises to the summit and then falls south. Heriot, Fountain Hall, which I believe Hunter will touch on in terms of level crossings and such like. This was our next new station at Stow. We had 2 existing tunnels, Beauchamp and Torwood Lee, Gala Shields and Tweedbank. Now, why Tweedbank? Historically, we can't get a car park in at Gala Shields for the new station because somebody inadvertently has built an Asda where the station used to be. So we've only got room, just if we, I don't even know if it's in the presentation, to squeeze in a couple of a platform and no more. So Tweedbank is just a couple of miles south. It's quite a big area, and we created the end of the line here. And quickly, everybody says to me, "Oh, it must have been easy. You're only reopening a railway in an old formation." Strangely not. There's, I pointed out the Edinburgh City Bypass. That's it there. And this was the first great challenge for us. And there's the broken yellow line is actually the route of the old alignment, but that's actually what we built. So as it says at the top, breaking new ground. Why did we do this? 2 reasons. To make it easier to build a bridge through here. And also here, when you see a couple of wee houses, this is called Newton Village. And the local, this is all tied into a bigger development. There's going to be a 4,000 home development built round about our new station there. The proposed track layout. Just a quick schematic. It's principally a single line with 3 dynamic loops. So there's a northern dynamic loop, there's the centre one, and there's a southern one. Interestingly enough, I mentioned earlier passive provision for a 15-minute service to Gore Bridge. There's Gore Bridge there, and if you can just see the broken lines, that's passive. It's actually active provision for a 4th dynamic loop to give us a 15-minute service to Gore Bridge. Some key outputs. 42 new bridges on the route, 95 refurbished bridges, 2 repaired tunnels, 1.5 million tonnes of earthworks. Actually, this is an old slide. I think that number actually turned out to be 1.8 million tonnes. 65 kilometres of track, because it's 50 long, but because of the dynamic loops, you get an extra 15. With 7 S&C units, 100 kilometres of drainage and fencing, because basically since it closed in 1969, nothing had been maintained. So we had to introduce new drainage over the whole route and new fencing. And as been pointed out in previous ones, you're there to build a railway, but we ended up building 10 kilometres of new road. And I'm going to pass over to my colleague Hunter, who's going to take us through some of the engineering challenges.
Okay, Andy mentioned the advanced works, and they were started in 2010, which was a big commitment by the government because there was this, what was known as the mastermind clause in the Act of Parliament, which was that if we started, we had to finish. So the Transport Minister had a sod-cutting ceremony in 2010, and that meant the clock was running. As Andy explained, the procurement of the main contract was quite an involved process. So in the meantime, there were quite a lot of advanced works which were taken forward. A lot of this was acquiring the land. The land acquisition was authorised by the Act of Parliament, but nevertheless is still quite a drawn-out process. There was safeguarding and scour repair works. The assets at this point hadn't had any maintenance for more than 40 years, so some of them needed urgent intervention, and in fact one bridge had to be demolished before it fell down. It gave a chance to begin invasive species control, site and vegetation clearance, both of which are necessary in order to be able to do proper surveys. We've heard a lot today about the importance of early surveys. One of the problems is if you've got 40 years of vegetation growth, you're not going to get a very accurate survey. PU diversions were taken forward during this time, and also accommodation works. And finally, the realignment of the existing turnback siding. The service is, from an operational point of view, is an extension of an existing service to New Craig Hall. And there was a turnback siding, and what was done during this period was that the turnback siding was realigned onto the new alignment, and the first 415 metres were built. And crucially, that meant that all the works were well away from the existing railway in the background. That meant our task of working on a greenfield site was a lot simpler. A little bit about the delivery structure. You see down the left there the 6 organisations that were the Tier 1 designers. We also had several sub-consultants working for them. Network Rail awarded a framework to BAM Nuttall, particular to the borders, and I think the strategy was, having awarded that framework, it was a simpler procurement process to award contracts. First contract was an ECI, which was an NR3 contract in March 2012. We then had an NR4 ground investigation contract to continue ground investigation, and that contract had a value of around about 2 million in itself. We had a mining remediation contract which had a value in the order of 20 million. This was to cover the mining works at the north of the job. And because we were able to take forward those 3 contracts, it bought a little bit of time to agree the target price, or target cost rather, for the main works, which was an NR12 contract. Within BAM, we set up an internal JV in order to bring expertise and resource from BAM Rail, which is our Dutch railway business, and BAM Contractors, which is our Irish civil engineering business. So although the contract was with BAM Nuttall, we leveraged the resources of the wider group. We had design agreements with each of the parties to the left there, and we also had obviously numerous subcontracts. Other key parties were NDS and Network Rail Telecoms. They were contracted directly by Network Rail to, in the case of NDS, deliver P-way construction materials and engineering trains and tampers. And the NRT did some of the GSMR design themselves, so that was the only part of the job that wasn't designed by the main contractor. So I mentioned mine remediation. I can't remember how many rigs we had, but we had We had Keller cementation and soil engineering, and we had every rig the three of them could provide. There was 12 kilometres of mine remediation. The slide on the right shows, as well as infilling seams, we kept coming across shafts, most of which weren't charted. So this shows a temporary works arrangement we had with a Bailey bridge over the shaft in order to create a safe environment for the grouting plant. Next, earthworks. I think the biggest point to make on earthworks is that we agreed on earthworks philosophy with Network Rail and both IP and the asset manager. And that was to treat the slopes as the existing railway. So the slopes were assessed by the same methodologies that would be used for operational lines. And where there weren't any defects that would normally require remediation, then we didn't do anything unless we were changing the alignment. The types of works involved, we did quite a lot of shoulder replacement, just benching out, and then that would be rock-filled. See one of the bigger rock-fill cuttings there. There's quite a lot of value engineering working with the designers. So this is a cutting down near Galish Hills, where we see we've got areas that are full rock blanket and other areas that are counterfort. We had quite a big design resource on site to enable those kind of decisions to be made as the works emerged. In terms of retention, we had about 10 kilometres of gabion baskets on the route. Again, similar to the previous presentation, although we were replacing a double-track railway with a single-track railway, in fact, but with double-track passing loops. Because of the need for compliant cess widths and the need in certain areas for quite large drainage, we did end up having to eat into the toes of the cuttings in quite a lot of areas. And that was quite resource intensive and expensive work. Again, a common theme, roadworks. This is Fountain Hall level crossing, which is here. This is the route of the railway. And you can see the extent of the roadworks we needed just for one level crossing replacement. This is the A7 here. Because we're now creating a new junction, this ended up being widened quite well off the edge of the slide there. So the threat of scope growth and level crossing replacements is quite real. Existing structures, Andy mentioned the extent of the existing structures beforehand. There's some examples there. We had a lot of overbridges which required track lowers through them to gain the passive provision for electrification clearances. We had quite a lot of these type of steel half-through bridges, and we had some bridges that you would not really recognise as a bridge at all. New structures, we tried to keep it very simple and keep it very repetitive, so we've quite a lot of very, very simple in situ concrete boxes for overbridges. Because we're on a greenfield site, these are very cost effective to build. Footbridges, we tended to stick to the standard designs. For retention, we used a lot of reinforced soil, and that was quite quick to construct. The problems, though, is that we were really stretching the supply chain because we needed thousands of square metres of these panels, and we were it was one of the big risks to program at one point, was simply finding people who could make them quick enough. Bridge here is a hardened green viaduct, which I think there's a further slide, so I'll push on. And I mentioned the city bypass. It's a dual 2 road. I think the daily figures are about 60,000 vehicles. So it was quite essential that we kept the traffic running, and the solution to that is a temporary road. It's quite a big investment, however, it suited our material strategy. We had a lot of material coming from this side from big cuttings in the new build section, so it worked quite well. It meant that we could build the bridge without a lot of threat of traffic disruption. A little bit about engineering integration. A lot of these things have been covered earlier in the day, I guess. So I will press on. Maybe the only thing I'll mention is progressive design. We mentioned before that the GRIP 5 to 8 contract was awarded in December, and we started construction in earnest in April. So it was a very, very quick start-up, and that required us to risk assess AFCing elements of the design long before other elements of the design were complete. And that required a lot of collaboration between the different designers and the construction team. Hard Green Roundabout, this was a good example of value engineering. Originally this was a 4-span bridge in the specimen design. We got that down to 2 very large spans. These are some of the, I think the second biggest precast beams that the supplier in Ireland had ever made, put in over the course of 2 weekends. So more on value engineering, we were under a lot of pressure to keep to budget and keep to time scale. So we did make some decisions. One was to take out the chamber spacing. The standard was 30 metres. A lot of people observed that roads are 90 metres, and after some debate, we implemented that. That had a saving over $1 million. We saved over $1 million in a change in the fencing spec. I've not got a figure for Glen Esk Viaduct, but again, it was changing from sheet piles to reinforced earth. And even something as simple as this little ditch, we saved over 100,000 with a change to the, it was originally precast segments. So changing to this concrete canvas was quite a saving. Construction challenges, conscious of time here, so just focus on this. This is our railway with its drainage, sleeper here. This is our earth moving plant. So the working in this kind of area and getting good outputs from earth moving is quite a big challenge, and you ended up sometimes using these tiny little dumpers like this. So it's quite a challenge. One success was we had within the limits of deviation a good source of rock. We got 500,000 tonnes of rock out of there, all processed into drainage stone and capping material. So that was quite a big win. A little bit about the challenges. Traffic management. This is the typical sort of access road. This is the type of vehicle we're using. It speaks for itself. A bit about supply chain. We had 1,100 people on site at the peak. We had quite a lot of political pressure to involve the local supply chain, which went well. And we've heard a bit about environment. I think we had more than 100 badger sets to deal with. This is an artificial badger set before backfill. And although we had an Act to Parliament that authorised the railway, it gave us development consent, it didn't leave us entirely with a free rein. The local authority still had to give prior approval to all structures. So this is a functional part of a wall, and this is the part the local authority wished for, and their wishes were not quite our command, but it was difficult because we had a programme to meet, so there was some compromises made. Communications was a big part of the job. We had 6 full-time staff, and they were some of the hardest working people I've ever met, to be honest, and they deserved all the accolades they got. Track installation. The method was basically to spread the sleepers just to the edge. The ballast was brought in by road for bottom ballast. Then the sleepers are spread out using a grab attachment. And then the long rail unloading unit is used to, this is 108 metre lengths, and this device just pulls them off the train and lays them down. The output with this is over 1 kilometre a day of single track, and including here the one bit of slab track we have in the tunnel, which would be a presentation of its own. Signal Power and Telecoms was then following on. By this time the clock was really against us, and working with Siemens and their subcontractors to really make sure we hit the dates at this point. We had 15 GSMR masts on the job. Stations were very, very simple. Precast platforms, nothing too exciting about them. We do have one lovely building at Tweed Bank, which is for the train crew, and we have a second building for the passengers. And that hasn't escaped some comment. So at that point, I'll hand back to Andy.
Okay, moving forward. Innovations. Novel. What you've got here is, I need to refer to my notes here, because I'm wary of my audience, and I need to make sure I get the wording right. Okay. What you've got here is, as Hunter's already mentioned, space was tight. This is, we had at least 3 areas in Gala Shields, and you can see the reinforced earth through here. This has historically been a level crossing. We weren't allowed to put level crossings back in. We had to lift the rail 5 metres in the air, 5 to 6 metres in the air, so we created this. Obviously built up areas. The bridge itself is designed with a robust curb, but the reinforced earth approaches are deemed as structures, and to put a robust curb on that was difficult. So what we introduced was, if it works, guardrails with gallery panels. Now the standard detail for a gallery panel is based on it sitting in timber. This one here is based on concrete, and it's after the borders rail. It now has become part of the NR-REPW standard design for gallery panels based on concrete. Hopefully that's correct. Moving forward, very quickly, lightweight signals, lightweight relocatable signals. What's odd about this? Again, because we introduced lightweight signals, we found that with a gravity base, we could introduce a very small gravity base. And you'll notice, anybody that's paying attention here will notice that it actually sits in the drainage line. So somebody's going to say, Christ, how do we maintain the drainage? Simple, you come along, you lift it up and you move it, because they're relocatable. And this saved us, unlike before where you would have to cut in there and actually put in retention. We've done away with retention up and down the route. Blown fibre cabling, this was to avoid cable theft. We have got a fibre optic cable, runs the full length on both sessions. On the right here, if it works, a fibre optic chamber was placed every 2 kilometres, and then compressed air was used to blow the fibre. And this is just the kit that was used to actually place it. It was mole ploughed in. There we go. And last but not least, this is Stow Station. You can actually see here, this is, because it's an existing alignment, it was on a 780 metre radius. What you can see here, it's very difficult, is a visibility display. That's the conductor's position, and he can't see all the doors. This gave us a problem. So what we introduced, everybody's heard of a DOO, we introduced a coup. Conductor-only operation. Now this isn't novel because it's done in Merseyrail and somewhere in London, but for Scotland this was the first time it was ever introduced. And the ScotRail had to negotiate with the unions for its use as well. Very quickly, you remember the lady in the tweed suit standing on 10 Downing Street? Here she is again, Madge, now in her 80s. She has been a campaigner right up to the point it was actually opened. Here you see an engine named after her. She's now got an MBE, and she was also the first non-project person. She was invited with the Transport Minister and was the first non-project person to get a run down the route on one of the route proving trains. Official opening was the 6th of September, public opening, but on the 5th we ran a golden ticket day. Willy Wonka and the Oompa Loompas were nowhere in sight. But basically this went to local school kids, and people were raffled, won tickets, and they were actually got a run up and down the route the day before a public opening. And last but not least, just not to outdo my previous presentation, on the 9th of September, a certain lady asked if we could move back the official opening to the 9th, because just so it could coincide with her becoming the longest serving monarch. So for anybody that's interested, this is the Union of South Africa steam train. Oh, sorry, I jumped ahead, but anyway. Here's some of the things up here. This is actually, we don't have time to show it, but the scenes in Gala Shields are unbelievable. This is Gala Shields. I think that's the procession up from Holyrood Palace, and this is Waverley Station. And there's a lady herself in Tweed Bank. And that's us. And I have to, for all the train buffs in here, I have to show this, if it works. This is the last great challenge. Towards the end of the project, Transport Scotland asked if we could assess the ability of the route to run steam trains. We hadn't designed anything, but we had to assess the ability. And it's for 6 weeks after the Royal opening, they ran steam train excursions up and down the route. And the intention is longer term they'll run more. Thanks for listening. Any questions?